its out-of-control climate satellite will hit Earth sometime this evening. Where exactly, they don't know. What they do know is that the risk of someone somewhere being hit by the upper atmosphere research satellite is 1 in 3,200. When it hits the ground, it will be travelling at 200 miles per hour, faster than a Formula One racing car. And scientists believe that when it comes through the atmosphere, 26 components weighing half a tonne will fall to Earth.
There are about 1,000 operating satellites in space at the moment, but if you look at objects larger than about 10 centimetres, then there's about 10,000 items. And clearly some of those are returning to Earth, they're in low Earth orbit, but for the last 40 years we've had typically one item a day come through the atmosphere. The vast majority get burnt up by the atmosphere and never reach to the Earth, and we have the odd example where items have actually made it to the surface of the Earth.
Well, on now to potentially even bigger science news. Did Einstein get it wrong?
Engage!
Captain Luke Picard may have been able to travel faster than the speed of light, but in the real world, it's a fundamental principle of physics that light is as fast as it gets. But scientists in Switzerland now think that the creators of Star Trek just may have been right after all. And our science editor Lawrence McGinty joins me now. We're leaving Star Trek to one side. We may not understand Einstein's theory of relativity, not many of us, but we do know that essential to it is the fact that you can't go faster than light. So was he wrong?
Well, on the face of it, it looks as if he was. I think you need to know a little bit more about these subatomic particles that they've been studying, so bear with me for just a second. They're very, very, very odd. They're called neutrinos, they have no mass, so they don't weigh anything, they have no charge, they're not negative or positive. And that means they can pass through almost any material. And what scientists at CERN have been doing, the European laboratory just outside Geneva, is firing them through the mountains to another laboratory called Gran Sasso in Italy, 732 kilometers away. Now you may say, if they can pass through anything, how can you detect them? And I think we've got some amateur footage which shows the detectors at Gran Sasso. They're big, big plates of lead, which slows down the neutrinos, and sandwiched with photographic plates which record when they arrive. And the results from this are quite amazing. Light would take 2.4 thousandths of a second to make that trip of 732 kilometers. Neutrinos do it 60 billionths of a second faster, and that means they're traveling about 6,000 meters a second faster than light. And Einstein said, you can't do that.
Well, the scientists obviously, they want to check this, don't they? They're not absolutely certain that it's right. But if it is right, what are the implications?
Well, they're enormous. The whole fabric of modern physics could start unraveling, because the fact that you can't travel faster than light is central to practically the whole of science. If that's not true, things like time travel become thinkable. But there's a big, big warning here. They've done this experiment 15,000 times. They've checked every detail of their measurements, but they don't really believe it themselves, because they're not claiming a discovery as they're entitled to do. They're having a big meeting this afternoon for other scientists to try and explain it.
Implications of time travel, as long as we don't go back to the beginning of this bulletin, that'll be all right. Thanks for that, Lawrence.